Hello, this is Scott. So, welcome to my YouTube series on advanced analytics and data science. So, today we're talking about simple forecasting methods in R overall. I've been doing a series on Statistica, and so last time you can see here S10, I covered some data management and specifically transform and standardize nodes within Statistica. Now I'm going to get back on this R series for at least a half dozen or so episodes. We are on number 7, so there are 6 recorded. If you want to see those, just look for R01, 02, 03, and with my name, or time series. Simple forecasting methods in R, you should be able to find it. So if you haven't joined me before, I normally do these things in one of 2 flavors. The first flavor is a industry specific or problem specific technology, data science overview, essentially what data science can do for you in a particular industry or problem set. And then I do a set of hands-on as well. This is part of the hands-on series, and it's part of the, again, simple forecasting methods in R. So with that, I'm going to shift into time series components. We actually covered this today. Not really covered a lot of hands-on. I don't have any R code to show you. We're just kind of setting up for this. But next time, we're going to be talking about exponential smoothing, and we'll actually get back into RStudio and R itself. So, but we need to set this up. So we need to talk about the different time components or components within a time series, right? And essentially, we have 2 flavors of this. We have we can decompose a time series into 3 elements: seasonal, trend, and residual. And we talked about this before in one of the earlier series, and you can look back at that. But I want to rehash and talk about the additive versus multiplicative decomposition. So in an additive series, mathematically, it kind of looks like you can break Y down into, the seasonal, the trend, and the residual part of the time series. And then obviously a question is when do you need an additive model? And that's when the variability, either the seasonal variability or the trend variability, is independent of the level of the series. What do I mean by that? So if you look here, on this plot here of beer, we see that there's a seasonal component, right, going up and down, up and down, up and down, and then there is a trend component, and these components are such that they are, it doesn't matter where I am in the series, they're moving up the variability is not changing. All right, so the seasonal component, we're not getting wider and wider as we go up, right? So the variability is the same there. And then also it is a linear trend, so it's additive in nature. It's a linear trend. I could put a line through there. That is going to be contrasted to multiplicative. And I guess I'll just go ahead and say that in multiplicative, the variation of the seasonal piece is, the variation is as I go up, it is increasing. So it's not constant through time. And also, it is exponential. You can see here that this is not a linear trend. This is not additive, but it's actually multiplicative. So the trend is exponential. How do we model that? Essentially, the time series Y sub t is equal to the seasonal trend times the trend component times the residual component. So, instead of adding, we're multiplying. And this often happens in economic time series. Okay, a couple more comments. if we look at breaking down, and we'll actually do this hands-on in R, the capability of decomposing these series, right? And looking at an additive example here, where I have new orders index, and the raw time series is in gray, and the trend cycle is in red. I can look at it across time and see. And then in R, I can break down the actual data, right? So this is this top panel is the raw data itself. And then R will let me break it down into a trend component, right? Which essentially both of these are the same thing that we're looking at over here. But then I can break things down into a seasonal component, right? So this is T, this is S, and then this is the remainder R in the series itself. So that's a way of looking at a additive time series. And then the other thing that we'll want to do is we'll want to be able to adjust seasonally. So, and again, we'll be doing this hands-on in R, but since we are talking about additive and multiplicative models, the additive model, we deseasonalize or seasonally adjust the data by just taking the original series minus the seasonal component if it's additive, or we take the original series and divide by the seasonal component if it's multiplicative. So hopefully that's straightforward. We'll be using some sample data in this book, which we talked about in the previous series. Again, next time will be R08, and we'll get into, this is not actually exponential smoothing. Next time we're going to be talking about moving averages. So with that, I will conclude. I look forward to seeing you next time. Drop me an email if you have any comments or suggestions. Thanks.